So in this case, we are going to consider as a continuation from our previous class, which is the introduction that we had. So like I said, we are going to work out each on its own in terms of the shapes that we can expect our tank to be in the form of. So we have got questions that we are going to consider, but do not forget, as long as you're dealing with the depth of the center of the pressure, the fluid pressure, this is the formula that you are going to use, and also the steps that are necessary for you to calculate that, as we mentioned in our previous class. So this is what you have. Even if you check your formula sheet, guys, you are just limited to that. Center of what? Fluid pressure. This is what you're limited to only. So meaning to say the rest is for you to know how to determine each section until the final answer. So we are given the first part of our question, which is a rectangle that a vertical sluice gate in the shape of what? A rectangle is installed in a dam wall. So meaning to say it is going to take the shape rectangular form. So we are given our sluice gate, guys. Remember, we've got the gate and the dam. So our sluice gate is in the form of a rectangle here, which we are given the horizontal side 8 meters. So that is 8 meters. The vertical side being what? Being 5 meters. So that is what we are given in our case. Then the top of the gate is 2. Take note, the top of the gate, our sluice gate, is 2 meters below the water level. We are not given the height of the dam or the depth of the dam. So in this case, they are saying sketch. Okay, no problem. This is what you're going to have. This is just our sketch, guys. So I want you to take note here. Remember, I said we are going to use our x-axis as the water surface or our water level. So meaning to say our diagram is going to be below the x-axis. All right, our water surface. So this is it, guys. This sluice gate was installed in a dam. But it's taken what? Its top is 2 meters below the water surface. So 2 meters from this, we're going down 2 meters. So it will be at -2. That is where we are going to put this dam. It's going to start from -2. Below is going to start from negative. We are installing it now. Remember, the y-axis is what? Our symmetrical line. So it divides our rectangle into 2 equal parts. All right. So it is going to divide our rectangle into 2 equal parts. And remembering that the height, this width, which is the height as we consider in our presentation, or depth, the height there is the one for the rectangle, the width of the rectangle, 5 meters. From this point to this point, it is what? 5 meters. But remember where it started to operate here. We started it at the top, which is what? -2. So that will affect the limit. So -2 -5 is going to give us what? -7. So -7 is going to be our limit here. From -7 to -2, because it is what? 2 meters below the water surface going down. So thus, in our conclusion, from 0 there going down up to -7, this is the height of the dam. Because remember, this sluice gate was installed into the dam. So it is the height of the dam. But we are not talking about that, guys. We are not considering about that. Okay? We are not considering about that. As long we can see, as long our limits are there for the what? For the gate. We do not calculate anything about the dam. whatever that we are going to calculate, it is of the gate, the Solus gate. Remember from our introduction, what I explained, that our calculations are not about the canal, they're about the retaining wall. When you have got your canal, but there we are not given its height to say it is 4 meters or what. The information was directly to the tank. So everything is there. The limits for Y are for the retaining wall, which is our Solus gate, the retaining wall tank. So we have the limits already, so there's no need for any adjustments in our case. Our Y is greater than or equal to -7, less than or equal to what? -2. Those are the limits that you're going to have, which is A to what to B according to our introduction. All right, so the representative strip, we said always our representative strip is what? Horizontal, which is the strip for Y. And our distance R is equal to what? Our distance R is equal to Y. If our tank is below the x-axis, our R is equal to Y, and our strip always, it is taken that is to be what? Horizontal. This is what you're going to need. All right. Anything else? The units in terms of the upper part here, it's what? 8 meters. Remember, this is the 5 meters for the width. So we need the upper part, which is 8 meters, but it is subdivided by the what? The y-axis. It has divided this into 2 equal parts. So we're going to remain with 4 and 4. So from here to here, this distance will be 4. It will be 4. This side, it will be what? It will be 4 again, negative. So this is what you need, guys. Since this horizontal distance is 4, it means it is the corresponding value of x there. It is the corresponding value of x, this distance. X is what is 4. So that is going to give us the relationship of the line. Remember, it's a rectangle. So for you to have that relationship, or a relation between x and y, relationship between x and what? X and y. It is just going to be x is equal to 4. You remember I said we use one end of the line. So you can use this one or you can use this side. So as for me, guys, I'm going to work with this side. All right. So the line that is going to be formed there is the line of what? X is equal to 4. We are forming a vertical line. Remember the equation of a vertical line. X is equal to what? X is equal to 4. So that is the condition. We cannot say x is equal to 2y. Remember, x is supposed to be a function of y. But we cannot say, we cannot have that for a vertical line. X is just equal to 4. Remember, our equation is x in terms of y. X in terms of y. All right, where is that part where I explained about the relationship? X in terms of y. So as long it is x is equal to, it's not a problem. It's not about y is equal, x must be equal to what? So this is it about our sketch. The sketch, the representative strip that we use to calculate the depth of the center of pressure. So the strip and everything, okay? Then calculate on number 2, the center of what? Of pressure, if the first moment of area of the Solus gate about the water level is given as 180. So we are already given our first moment of area. It is given there. What we need is to find the depth, which we do not know, but we are given that our first moment of area, first moment area is what? 180. Remember when I was saying for a diagram that is like this, where the tank is below the water surface, below the x-axis, our first moment of area, when we calculate it, it must be a negative value. Do not forget that. Your first moment of area is supposed to be what? A negative value. There they just gave you the magnitude, but you must know that according to the method that you're using, it's what? It's a negative. So that's negative 180 cubic meters. If you were not given and you are the one who is calculating, you're going to see that your answer is negative 180. But for the sake of time, we are going to calculate it on another question. For this one, we are already given. Let's just leave it like this. Let's move on to the second moment of area. Since we are to calculate the depth of center of pressure, we must have the second moment of area according to our calculation. So second moment of area is given as what? Remember, we say this is r squared dA taken from A to B. I'm going to use the limits A to B so that we understand each other with our formula sheet as well. So R is equal to, it does not change, guys. R is equal to Y. For this diagram below the x-axis, your R always is equal to Y like that. It's not going to change. Oh, it's a fixed thing. That is not going to change. Your R is equal to Y, and your dA is equal to 2x dy for two portions, two sections that you're calculating, which are identical in their area. So this is it. It's something that is not going to change. R is equal to Y. Our dA is equal to what? 2x dy. So we substitute this into and integrate. We are done. So this is it. Let us have this. So it's going to be A to B. Our R, remember, it's what? It's Y. So it's going to be Y squared. Our dA, we substitute our dA, which is what? 2x dy. So this is the original formula, always again, that you're going to use to determine what? To determine the second moment of area, where our x, this one, is supposed to be in terms of what? In terms of y, as we explained that, in terms of y. So when we say x is equal to 2, remember 2y to the exponent of 0, it's not a problem. As long it is x in terms of y. X is equal to 2, it's fine. X is equal to 4, x is equal to 5, still it's okay like that. As long we are not having x there, we have substituted it. But in our case, x is equal to a constant. So are we going to fight with that? No, we substitute as it is. Okay. So this is our condition. We can even take out the 2. So this one, we can take it out. Remember, we said our x from our relationship, x is what? X is what? X is 4. Remember that x is 4. So we can take out that 2 here. We can take it out of the integral. This 2 here. So it's going to be like this. To the integral of y squared times x dy like this. And our limits, they are taken from where to where? -7 to -2. All right. So that's our A and B. That's our A and B. So let's substitute our x and the limits as we have got these ones. So that's to the integral of y squared times our x. Our x is what? Is 4. But if it is any line or it is a parabola like this, it is going to be x in terms of y, maybe 3 over 2y plus 7. You substitute that one. But in our case, it is what? It is a constant. So you're going to substitute that constant, which is what? Which is 4, just like that. So this is it. Remember our limits A to B, -7 to -2. That is it. The limits of the tank, the retaining tank that is having the water, is taken from -7 to -2. So that is it. Take the 4 outside. 4 times 2, that's 8. We can integrate what is remaining here, guys. Y squared with respect to what? With respect to y. Remember integration. Add 1 there. So it is going to be 8. That's y to the exponent of 3 over 3 with our limits -2 and -7. So I want you to simplify this. You substitute your upper limit and your lower limit. So upper limit in place of y there, that was going to give us 8. If you substitute the upper limit, that was going to give us -8 over 3. Okay, minus our lower limit. If we substitute -7, that was going to give us -343 over 3. So this is what we were going to have. So we simplify, not forgetting negative, it's positive. So whatever that you're going to have here, multiply by what? By 8. So it was going to be 8 times 3, 35. over 3. This is what you're going to get from this one. So that is going to give us 2,680 over 3. Second moment of area, remember? That's meters to the power of 4. Units to the power of what? Of 4. So this is what you're going to have. You have got the second moment of area. Given the first moment of area, guys, we can calculate the depth of center of pressure. This is what you just need. Remember, your first moment of area is given negative 180. So you're just gonna substitute. So therefore, the depth of center is going to be 2680 over 3, all right, which is our second moment of area over what? The first. So this is to the power of 4 over the first moment that you're given, which was negative 180 cubic meters. Remember, this one we were given. So we just have to substitute. So this is it. We can simplify. That is going to give us negative. So if we simplify, we're going to get a negative. That negative 4,963 meters. Just like that. Since it is what? Below the x-axis. The answer must be a negative. Do not worry about that negative. Leave it as it is. Leave it as it is. You're done. So take note of the question. There we had to calculate the second moment of area. So this part, guys, is not going to change. It is a repetition, guys. It's going to be a repetition throughout. A repetition. Just read to understand the question. Understand the question. On understanding the question, it's important. Let's look into this question, which is a typical exam question that we are going to use. That was August 2014, all right? If I'm not mistaken, it's supposed to be August 2014. So we want to look into this and see. So if you are on membership, there is a question that you've been attempting, then you do not understand it, let me know so that we can add those questions. That is if we've got time. And for those who are watching, who will be watching for next trimester, we can utilize that to send the questions earlier so that we can work on those ones. August 2014, they are saying, all right, for the sake of information, let me make my diagram on top like this, all right? They are saying here, there is 5.41, there is a rectangular canal, all right, exactly. There's a canal there, okay? Let's see. So you see these boards sometimes, guys, when you want to explain, that's when they start to just misbehave, like they, I don't know, they've been drinking maybe. So let me see. 5.41. A vertical wear in a rectangular canal. All right, so it is in a rectangular canal. So take note, this information is not about the rectangular canal. It is about the vertical wear, just like the retaining wall. The retaining wall. The information they are giving us here, it's about the retaining wall. Just like that information they gave us, there's a dam or this and that, but they gave us information not of the dam but of the retaining what? The retaining wall. So do not worry about it. Is in a the rectangular there is for the shape to say in the form of a rectangle. But these dimensions, this one to say 6 meters wide, 3 meters high, they are not of the canal. They are of that air, vertical, in air, is. The wall is the wall that we placed in a canal. So we are not given the information about a canal. No, we are given about what we placed in a canal. So it is what? 6 meters wide, 3 meters high. 6 meters, 3 meters. The top of the weir, which is our wall, is 3 meters below water surface. So when we are to place it, it is 3 meters below the water surface, meaning to say our water surface, x-axis, This is our x, this is our y, like this. So it is 3 meters. So we must consider the 3 meters below. 3 meters. So it will be at negative what? At negative 3. That's where we are placing it. Remember, the y-axis symmetrical, dividing this into two equal parts. So we're going to have our rectangle like this. Remember, our rectangle also has got its width. The width of the rectangle is what? Is 3 meters. So meaning to say, as I am going down here, I have got the 3 meters of the width. So it's minus 3, which will end up at what? At minus 6. So these are the limits that we are going to use, minus 6 and minus 3. The limits which are on the what? Our where? Our wall, the vertical wall that was being placed. These are the limits, that not the limits of the canal. So the question someone is asking, so what is now the height of the canal or the depth of the canal? This is our canal, guys. From zero, remember I said the canal is always fixed to the surface of the water. So from 0 here up to negative 6, like this. So this is the height of the canal. They can give you that height. You must work it. You must work from there. But in our case, they never talked about that height of the. No, no, no. It's about the. They gave us this one is 6 meters wide, 3 meters. This about the wall, the tank that was placed in a canal. So 6 meters is the height of the canal, because the canal is our water storage. This is the one that is carrying water. This was placed into it. But do not worry about the canal. You have to be very thankful, because they never mentioned about its dimensions. We're just given direct what we need, the retaining wall. This is it. So we are done, guys. Let's save our strip as it is always horizontally given. So that's the strip for y, and our distance r is given as what? As y. So in our case, the top is subdivided into two parts. So 6 divided by 2, that's 3 meters here, 3 meters here. So this is the distance from here to here horizontally is 3. This is negative 3. So meaning to say, along the x-axis, the corresponding value there is what? Is 3, the horizontal distance. So therefore, the line, its equation is what? X is equal to 3. That is, here they're saying, make a neat sketch, this and that, that you use to calculate the depth. All right. So that is it. So you can even write our equation. X is equal to what? X is equal to 3. That's the relationship that you're going to have. And remember, our R is equal to what? Our R is equal to Y, guys. This one is direct. It's not going to change, like I mentioned before. So you have got your equation. X is equal to 3 from one end of the line. From one end of the line. Just consider one end. 5.42. Calculate the area now. Calculate the area now. Of what? Of the where? The wall that you're given there about the water surface by means of what? Integration. So we are back to that concept. So this was 5.41, 5.42. So this is what we're going to need. All right, so 5.42, guys, we're gonna need. So when they say area, the area moment is the first one, the first area moment. All right, so this is the integral of RDA from A to what? From A to B. Remember, this is what we have there. R is equal to ID, guys. This always. As long our tank is below the x-axis, always use that. So R is equal to Y. We substitute. Our R is Y. Our dA represents what? It represents 2 times area, 2x dy. Remember, two portions that are equal from A to B, where in our case, y is greater than or equal to negative 6 as our limits, less than or equal to negative 3. So that's from A to B. So this is it. So we can take out our 2, this one out of the integral. So that's 2, A to B, y times what? Y times x dy. So we're going to substitute our x with its equivalent, which is what? That's the limits minus 6 minus 3 y times our x. Remember, x is what? Is equal to 3. So this is it. So we can simply simplify this, take the 3 out of the integral. So that's 3 times 2, which is going to give us what? Which is going to give us a 6. So you take this 3 out of the integral, then you can integrate what is remaining with the given limits that we have. So that's y with respect to 2y. So this is 6. We integrate y there, guys, is y. Then we add 1. Y to the exponent of 1 plus 1 is what? Is 2. So that's y squared over 2. Our limits, negative 6, negative 3. Let us substitute upper limit minus the lower limit. Definitely, we are supposed to expect to obtain what? A negative value from there. We must expect a negative. This is first area moment, remember? So upper limit, negative 3, you substitute there. It was going to give you 9 over 2 minus the lower limit you substitute there, it was going to give us 18, all right? Just positive 18. Okay, so this is what you're going to have. Then multiplying 6 into the bracket, and this is going to give us negative 81 cubic meters first area moment. You're done. Just like that. Integrate, as you can see, it's integration that is left there. Here, guys, it's gonna be like always for the first area moment. As long this is below the x-axis, your r is equal to y, your dA is 2x dy. You substitute the x with what it represents, then you integrate just like that. Just like that. So we have got our first area moment. All right, so this is it. Let me just remove this one and calculate the next one. So that's negative, we obtained what? Negative 81. Negative 81, okay? So our first area moment was negative 81. Then 5.43, calculate the second moment of area of the weir about the water surface as well as the depth of the center of pressure of the weir by means of what? Integration again. All right, so let us continue as we do understand this one is just a continuation. The second moment of area or the second area moment. All right, second moment of what? Of area is gonna be r squared dA. So remember the properties, r squared. All right, let me see, r squared dA from A to what? To B. Remember, r does not change. Our r is always equal to y, and our dA is what? So we're going to substitute r squared as y, so it's y squared. Our dA, remember, it's always 2x dy from A to B. Just like that, you can take the 2 outside. That's in your hands. So this is it, guys. The only part that changed is the y squared, r squared, r squared, r squared, y squared. So let's substitute our x. Remember, our x is what? Our x is 3. So we're going to substitute 3 there. So that is going to be 2 integral. The limits, the moment we substitute that, also put the limits. So that's y squared times what? Times 3 dy there. This is representing our x. Take it outside of the integral. That was going to give us what? 6. 3 times 2, 6 integral of what? Of y squared. So let's integrate this with respect to y. We're just going to add 1 to our exponent. That's 3. So it was going to be 6 y to the exponent of 3 over that exponent 3 from negative 6 to negative 3. Substituting the upper limit in place of y there, if we substitute our upper limit minus 3 in place of y, we're going to get negative 9 minus the lower limit. If we substitute negative 6, it was going to give us negative 72. All right, so this is it, negative, negative, that's a positive. So you multiply to the 6, which is outside, the answer that you get, you're going to get 378. That's meters to the power of 4. Remember, it is the second moment of what? Of area. Just like that. With these two guys, you can now calculate the depth because you've got the first area moment. So the depth of center of pressure can now be determined from these two. So therefore, in our conclusion, therefore our depth of center of pressure is going to be second moment of area 378 over the first area moment negative 81. All right, just like that. Just like that. So this was going to give us negative 14 over 3, which is negative 4,6672. 3 decimal places. You have got the exact value that is representing what? The depth of the center of pressure of the wear or of the wall that was put into a canal. But we are not focused on the canal. We are focused about the retaining wall, guys. Just like that. It's an exam question, this one. 10 marks, 4, 8, 10. Just like that, you've got 10 marks. So, guys, you say you are failing mathematics N6. No, guys, you just need time. Time, like maybe some of us is because of these courses, you'll be going to work. So finding time, this and that. But if let's say there's time, we have got time on this one, guys. All of us, we must have distinctions in our mathematics N6. We must have distinctions. So it's another thing that we must correct. It's also that some of the introductions were not yet properly covered. We just did question papers, and some of you be asking, where is this one coming from? Where is this one coming from? The question is not making sense because you do not have an introduction to it. So now that we have got introductions, I think these questions can make sense. Another typical exam question that we are going to use is of August 2016. So I'm going to mention other question papers later on that you can also use, which have got a rectangular canal. You try using the same concept, you're going to obtain all the marks. Look at this one, it was even 3, 6, 10 marks. 10 marks. It's a lot, guys, in exam. A rectangular way again. So this one, guys, is just like the previous one, but they said, all right, it's different that the top here, they are saying, all right, let me say, I said, this is what? August. I just need to finish, guys. They said there's a lot of questions that I need to answer after this. A vertical wear in a rectangular canal is, the information is about the vertical wear, not about the canal. Yes, the canal is giving us the shape because it is placed in a canal. So it's a good question. It's a direct question. There are no adjustment when it is like that. There's another one which is an adjustment. I'm gonna look for those ones. You'll see. So not a problem. We're gonna have time for that one. 3 meters high. So it is 3 meters high. It is the height, the width. Then 4 meters wide is the length, the top part or the bottom. So that is 4 meters. Then the top of the wear is in the water. The top is in the water surface. So this goes to that question that I explained before about a canal, to say that when the retaining wall takes the shape and it's on the water surface, remember this one, it's our water surface or our water level. When it is at the water surface, it is exactly the same thing as the canal. It is exactly the same thing. It's different from when a canal is this, when it is just a sluice gate or on its own, like when it is operating with its own properties away from what? Away from the canal. This one, it is exactly the same thing. But though it does not affect our question because we have it as a retaining tank and our calculations are made on the retaining tank. So no effect at all. No effect at all. All right. So it's just for explanation's sake, guys, that we must understand where it is coming from, because there will be another question which will be just, there will be just a small statement that is, guys, they want just a small statement affects everything. So that is why I'm explaining that, so that if you have that small statement, you can notice it. All right. Remember, y-axis symmetrical, and the top is on the what? The top is on the water surface. So this top is on the water surface. So guys, it is just normally like this. The top is on the water surface. It is not 2 meters deep. It is not 2 meters below. So it means it is taking exactly the shape of what? Exactly the shape of the canal from the top. Anyways, this is the height that we are given, 3 meters as our height. So from 0 to minus 3, 0 minus 3. All right, 4 meters. So it means divided by 2, that's 2 meters here, 2 meters here. So this is 2, this is 2. So that's it. We can have our representative strip. Our representative strip always horizontally given, always horizontally given. And the equation, our relationship is the equation of the line. Remember, the top is 2 meters. So at this point, it means x is what? X is 2. That is the equation of the vertical line. X is 2. So we've got the relationship between x and y there. When they are saying, here, calculate the relation between the two variables x and y. Our relationship in this case is just x is equal to 2. There is no y there. It's a vertical line formed, a vertical line. X is equal to the number that is there. I think we are done for this one. We're gonna need what? The y, the distance. All right, guys, this is what you're just gonna need. You have all your marks there, all the marks, you obtain them. Then 5.42, they will now want you to calculate by using integration the area moment of the weir, which is that tank about the water surface. So we did this question, guys. We said this one, it is a repetition. It is not going to change. So 5.42, our first area moment, first moment of area is given as the integral of RDA from A to B. So remember this, the limits of the tank are from what? -3 up to 0. So those are the limits that you're going to use. Remember, our R is always equal to Y, and our dA for 2 sections of areas calculated is 2x dy, which is not going to change. So just gonna substitute. So that's why our dA is what? Is 2x. 2x dy. So that is it, guys. Just like the previous case, take the 2 outside. That is going to give us what? 2 integral of y times x dy, a to b, where our x is what? Where our x is 2. We can substitute that x, which is what? Which is 2. So that was going to give us 2. Whilst we are substituting the x, also put the limits -3 to 0. So that's y times our x, which is what? Equal to 2. If it is in terms of y, you substitute that which is in terms of y. So 2 is a constant. Take it outside of the integral again. 2 times 2, that's 4. Just like that. Guys, you're done. You integrate. You integrate. You're done. Y squared over what? Over 2. Are we seeing that it's a repetition? Only that the diagram is the only thing that changed, but this whole thing is just a is just a upper limit minus what? The lower limit. This was going to give us what? Something like negative, it's going to be positive 9 over 2. Yes, something like this. So that's it. Going to have a negative answer just like the previous questions. So this was going to give us -18 cubic meters as you are calculating the first area moment, cubic units, -18. I don't know if I'm fast. If I'm fast, some of us were complaining, we do not want AI. What is AI? What yini le? Yini yena le? Yini le? Yini le? It was AI, guys. It was AI. But anyways, we are going to leave it and focus with the one that you want. Some of you guys, yeah, you wanted to fight, guys. You wanted to fight. You wanted, some of you wanted to see me face to face to say, who is this guy who is bringing AI? Ngathi into zabalungu, into zabalungu, ivoice yabalungu. You want your voice. Which one? Which one is this voice? Voice Yabalung. All right. Yabalung, Yabalung, Yabalung. Okay. No problem. Let's try the African way. 5.43. Calculate by using integration the second moment of area of the wear about the water surface as well as the depth of the center pressure on the wear. All right. So it's a continuation again. I'm not going to waste your time here because the only thing that changed are the limits. I just wanted you to see when they say the top is the top of the wear is in the what? In the water surface. That's the only thing that changed on the water surface. So it's going to be from 0 to -3. Otherwise, nothing changed. So let us quickly rush and have it. You see that AI now, that is where it can rush. Me, I cannot rush like AI. I have to write like an African man. All right. Anyways, second area moment is given as what? R squared dA from A to B, our R being Y. So that is Y squared. Then the dA is what? Is 2x dy. We're going to substitute. Okay, you can even take this one. Even substituting here, it's fine. You can even put that x there. Taking out, guys, is just for you to go back to the basics to say, okay, this is exactly the x that I'm substituting. I want to properly see it. That is the only thing. Otherwise, there is no need for that. You can even just take it out, the constant later on. All right. Our limits -3 to 0 y squared. What is our x? Remember, our x is 2. Our x is 2. All right, so that's it, just like that. So we are going to take out the 2. We can even integrate here, no problem. Or you can just take out that 2 for formality. Formality. They are saying Meson African motives. Formality. All right, no problem. That formality, guys, it has some advantages. I'll be using it for, guys, for us to get used to some engineering techniques which are just like even in the industry, you see, it's a formality to you are working today each and every day to go and do the same thing unless there's a fault which is something that it is massive or something. But otherwise, guys, if you are not if you don't see it in another way, guys, you wake up the whole year to fix the same thing or to work out on the same thing, then you'll be wondering, is it what Meson African Motives was teaching us? It was that. That is the thing. I was teaching you that so that you do the same thing. You are used to that. That is why we've got these maths. You get bored doing this maths. Then you start enjoying even the work. You just get bored. Then you start to enjoy it now. So that is we are also training for fault finding, doing these calculations. That thing to say you are thinking a lot, even fault finding, you think outside of the box, you see, that is the thing. It is opening another mind, which someone cannot have. But there are some who have got that mind. There are some other guys who do not even know maths, but they know industry. Yo. Anyways, let's finish. As we are doing maths for now, we are not in industry. So therefore, our second moment, I mean, our depth of center from the second moment, 36, over what? The first moment, which we calculated negative what? -18. So that is it, guys. That is it. That was going to give us what? -2 meters. So this is it, guys. As you can see, we have got our final answer. So let's revise a lot of questions, as many questions. And like I said, guys, there will be no more AI on our main channel. We are not going to have that. We are going to use what you want, guys. What you want. What you want. Sizoyenza njalo. No, sizoyenza njalo. Hayi, sizoyenza njalo. Wathi sizoyenza njalo. Okay. Also try these questions. As an individual, I want you to try this. November 2018, August 2025. Okay. These ones, they are also on a rectangle type of a question. So use that to see if you truly understand the concept of a rectangle for calculations made when it is below the x-axis. our x-axis as the water surface or as the water level. Our diagrams that we are going to focus on are like that. If you are using something, guys, if your diagrams are above the x, you are going to have a different way of calculation, but the answers will be the same. Only they'll be differing in terms of the signs. You'll be having positive values. All your values will be positive. But there'll be differences in terms of how to find your error and substitution, this and that, which I do not want to make confusion. So with these guys, you know when it is below the x, always your error is equal for each and every shape that you're going to do. For those who are not on membership, for all the questions that you're going to try, always put your R as y. Your dA always as what? 2x dy. We explained where this one came from the two identical shapes that you're calculating their area on. From the strip of y, it's x dy, x in terms of y. So if it is a line, calculate the relationship y is equal to mx plus c, then you make x the subject. A parabola y is equal to a x squared plus c, then you make x the subject. Find the equation. Just like here on a rectangle, we had to find from the side of the rectangle. But it's only that the side of the rectangle is what? It's a vertical line, guys. So we cannot fight that one. We cannot fight it. It is a vertical line, all right? Sorry for that. It is a vertical line. So the equation of a vertical, all vertical lines from straight lines, from our straight lines, these vertical lines, they're in the form of x is equal to x is equal to x is equal to what? The value of x where it passes, if it passes a 2, x is equal to 2. That's why your y-axis is called what? X is equal to 0. So here we just want to know what is the value of x at the end of the what? The rectangle. The value of x at the end. We have got our equation. We have got our equation. So when it is now something else, guys, which is maybe we are now talking about maybe it's a triangle like this, guys. Don't take that information. It does not apply. This is no longer a vertical line. It's a slanted line. Y is equal to mx plus c. That's how you must go out. So you must have 2 points, at least this point and this point. They are enough for you to have the equation of a straight line. They're enough. So use that. It's a parabola. Y is equal to ax squared plus c for this type of a graph, which is what? Symmetrical about the y-axis. This is the format that you use. Where c is the y-intercept. All you just need is to find the value of a. So this is it. The process here, the substitution process here, it is the same for R. It is the same. Your x is the one that, from what you made x, from the one that you found here, you made an equation, then you're going to maybe x is equal to y over 2 plus 3. That x is the one that you will substitute in place of x here, okay? This is the one that we simplify here. You substitute there in place of x. Then you integrate according to the one that you have. Is it going to be by substitution? Is it a direct integral like this one? It was just a direct integral. So we don't fight here to now start doing substitutions. No, it's a direct integral that we have here. It's a direct integral. When it is a direct integral, integrate. Where there's a need for a substitution or maybe by inspection, use that inspection. You are under integration at the end of the day. You are under integration. So all the best, guys, as we are revising for our examinations. Let's do as many questions as we can. Just if like basic, basically like each type, according to your question papers, you see that they do repeat the same, ask the same way they do ask these questions. They do repeat. So let's revise as much as we can till we meet again.